Oh, that's okay.
Wow, really busy today.
Morning. Okay, I imagine besides the beginning of class, nothing eventful happened with the quiz. Any questions about that? Okay. I guess the sub went to the wrong classroom.
Oh, yeah. I'm sitting over there.
Yeah? It's like, where's my class? And you're
Yeah,
like,
'cause
where's the sub?
I looked up when you came in because I could tell it wasn't that teacher.
Yeah.
There's nobody in there.
All right, well, while this loads, I'll go ahead and put the bell work on the board. It's pretty short. So it is a really hard problem for being short. So an airplane is traveling at 724 kilometers per hour at a bearing of north 30 degrees east. And you have a wind that's going directly from west to east at 32 kilometers per hour. What is the resulting vector? Its magnitude and direction. 4 minutes. You get this one, I think you mastered 6.3. And like, I don't know, an entire unit of physics. Morning. Is that how it normally looks? I feel like normally it doesn't have the top bar across, or does it normally have this? Maybe it does. Like where you can see the tabs. Maybe it does. Howdy, howdy. Okay, so if there's a few things that we have to do to ensure we get this problem solved correctly. The first thing is to determine the correct angle for this plane. So if you have let's try that again. Let's try that again. There you go. That's our north and south axis, east and west. So if our plane is traveling like about here, 724 kilometers per hour, and this is 30 degrees. What is the actual angle for that plane going to be? Yeah, we really need to use this angle, 60 degrees. And so if we use this angle, this magnitude, we can find the vector in its component form. Let's call this vector 1. Does anyone remember how? We're going to take 724 and multiply it by the cosine of 60. That'll give us our x component. And if you do 724 times the sine of 60, that'll give us the y component. Does that make sense? Like imagine you're creating a right triangle here, right? Where this angle is 60 degrees. The opposite would be 724 times the sine of 60, and the adjacent would be 724 times the cosine of 60. Now we just do those in a calculator. Make sure your calculator's in degree mode. You should get 362. Exactly. Because the cosine of 60 is just a half. And then if you do the other one, you'll get 627.002, or if you want to be more precise, that is just 362 times the square root of 3. Or because the sine of 60 is just the square root of 3 over 2. Right, so a half of 724 is 362 times the square root of 3. All right, the second one is even easier to write as a vector, the wind. Because the wind is just going directly from the west. So it'd have an angle of 0. And we could write it simply as 32, 0. It goes 32 to the right and 0 up or down. And then all we're going to do is we're going to add these two vectors together. And then once we have a component form, we're going to find its magnitude and direction. So the resulting vector will be the two added together, or 394 and 362 square roots of 3. I think this picture took up too much room. Why did I draw this picture so big, Mr. Lake? All right, to find its magnitude, we're just gonna square root 3 the components, the sum of the components squared. Type that into the old calculator. Oop, parentheses. And if you do that, you should get 740.519 kilometers per hour. So the plane is actually going faster now, which should make sense because it's a tailwind, right? Yeah, it's coming from the tail. And then, okay, I'm going to delete this to do the angle. And then the resulting angle, right, is just the tangent inverse of your rise over your run. What? $740.519. And the nice thing about this is our resulting answer is in quadrant 1. So whatever the calculator gives us is actually the answer, right? Our X and Y values are both positive, so we don't need to worry about moving this angle to a different quadrant. And so if you do that, the tangent inverse of 362 square roots of 3 divided by 394, you get that the new angle is about 57.855 degrees. So basically the plate was pushed, what, 2.5 more degrees or so to the east? Or 2.5 more degrees clockwise. Yay? Again, the key is to write your answers in component form. And then when you ever have two velocities working together, you just add them together to get the resultant velocity. And then from that, you're doing the stuff that I think we do the best. Plug it into this formula to get its magnitude, plug it into this one to get its angle. Today, we're going to do more operations with vectors, particularly the dot product, which is a little weird, but also pretty easy. I think you'll find today is a pretty easy part. This lecture will probably take today and tomorrow, so there's no homework due tomorrow. Next assignment is due Wednesday. All right, is there any questions or does anybody need more time to write? Okay, let's talk about, so today we're going to do dot product, finding angle between two vectors, and determining whether or not two vectors are orthogonal. I think that's probably as far as we'll get today is A and B. And then we're going to write vectors and sum in two components and use vectors to find work. All right, so here is the dot product. The dot product of a vector u with a vector v is written kind of like multiplication, and it's like multiplication, but also not. It's u dot v, and you take the first components or the x components, multiply them together. You take the y components and you multiply them together, and then you actually add those two products together. So the result of a vector being dot product with another vector is actually a scalar, a single number. These down here, again, you can write, you don't have to. But here are the properties that come along with dot products. It is commutative. The zero vector will take your scalar to 0. You can distribute it through a parentheses. This one is okay, actually. If you were going to write down any of them, this last one is pretty important. A vector being dot product with itself will result in a scalar which is just the magnitude squared. You could use that identity as a shortcut to do some of your problems. Or use that property. And then notice how scalar distribution works is kind of weird. If I was to distribute this C through the parentheses, I only actually distribute it to one of them, either to U or to V, not to both. Because remember that U dot V is actually just a number, right? And so C times that number, like let's say it turns out that the U dot V is 6, right? The 2 times 6 is 12. If you multiply both U and V by 2, you'll get 24. You'll end up multiplying by 2 on extra time that you're not supposed to. So if you distribute, you only do it to one of them. Otherwise, you'll double multiply and have to, go to jail, not pass go, not collect $200.
Okay.
All right, while you write, let's see if we can fix this copy. Oh yeah, there we go. I went the healthy route today and got an almond milk espresso. But like all the flavoring was at the bottom and all the almond milk was on top. So it was like just drinking straight almond milk. But now look at that. That's evenly distributed. All right, how are we doing? Do we need any more time? Are we good? Okay, let me show you some dot products. You'll see that this ain't too bad. This is actually a pretty fun lesson. Oh my, what is this? What is this? Okay, apparently Google Slides does not like the special character of the dot. So that's a dot. Dot. Ignore the rectangle or the square. All right, so if we want to do U dot V, where U is 4, 5, and V is 2, 3. That's pretty easy. We're going to multiply the first components together, 4 times 2. And the second components together, 5 times 3. And then we're going to add those two products. So that'd be 8 plus 15 or 23. Again, notice how the final answer is just a single number. It's not a vector anymore. If we try this, now let U be 2, -1, and V be 0, 2. If we want to do the dot product of these two vectors, I'm going to take 2 times 0 plus -1 times 2. Which is 0 minus 2. Which is -2. You know what I should have done? I should have put out one of those worksheets that had like 60 of them on there, and then you get 60 seconds to do it, and everybody does it and sees who can get through the most in the minute. That would have been fun. I might write that down in a note to do next year. Or maybe we'll do that for homework tomorrow. Those were my favorite days in old grade school math. Those worksheets, you had to go through as many They still do those? Now they're frowned upon now because it's competitive, right? And if you get more than somebody else, the other person feels bad. The key part of that is just to be like, face, you suck at math. I'm better than you. No,
I don't think our teachers would enjoy it.
no, I don't think they do them anymore. Actually, I don't know if that's true. I feel like I had a meeting. Okay, anywho, I'm gonna stop. Oh, does anybody need more time? I imagine no. It's okay if you do. Okay, then let's have you try some. Try these two. No, I think I had a meeting that said that actually is a good educational tool. If instead of comparing yourself to others, you then do it again later, and you compare it to yourself.
I was gonna say,
But
but
it's also
by
fun.
processes, it's going to still be
Sure.
comparing you to others.
Sure, people will still compare to others and they might feel bad, but at the end, when they improve, they'll feel better.
They don't want to feel bad, get better.
Yeah,
But, I mean, kids are gonna compare anyway, so.
But-
There are other benefits to it.
sure. Of course, there's also selection bias in this discussion right now, because everyone in this classroom is good at math, right? If we had this conversation in maybe like a algebra 1 class, they might say, oh, I don't know.
In a class where they're still having.
Yeah. Those actually work.
Good.
Yeah.
NBA.
That's right.
But really,
You're
like,
good.
a whole lot of things. can go.
Well, sure.
Like you can brag to people about like having a higher test score than that.
Yeah.
I was gonna say, kids
Well,
will
they
make
should
everything
probably just
competitive if
eliminate
there's a way to-
tests.
Yeah, we should eliminate tests and just bring back this little timed worksheet thing.
I think I'm gonna take one out of the old loop display. Just get good. GITGD. Yeah.
That works in any situation except for taking tests.
Oh, I forgot to start the timer. I was too busy talking about the activity. Grr. All right. Do we need more time? I feel like we've spent more than 3 minutes.
I feel like, aren't you wearing pajamas today, Mr. Root?
I did not realize that this was Spirit Week.
Well, you
For
better
some
wear-
reason, I thought it was last week, and I was like, nobody's doing anything. Wow, this is so weird.
You better wear sequins tomorrow.
Sequence? I don't know if I have anything in sequence. Emily, you want to start us off here with this first one? What do I do with the old 1 and 4? Just multiply them together. Same thing with the 3 and the -2. And then if you add those, what do we get? Yeah, 4 minus 6, -2.
I keep doing this.
Yay, thank you, Emily. Let's see, let's go. Clockwise 4 will be odd, counterclockwise will be even. That's odd, so Amaya, what do I do for this second one? Yeah, and what'd you get? That's great. Good job.
These questions are so easy.
Yeah. I told you you're gonna have fun today. Isn't that great? It's like multiplying, but also not really.
Yeah.
It's kind of, it's like a distributive multiplying and then adding.
I already know you're gonna like make the problems look hard. though.
Yeah, next
We
year.
gotta.
I actually, to be honest, I don't know if they get much harder. Like here's the hard ones, okay?
Yeah, see,
Try these.
I already don't know.
You're gonna be okay. Once you try them, you'll be like, oh, these are easy too. Oh, speaking of which, for my remote people, yeah, sorry that you couldn't get in the other day. It looked like they weren't able to open up the class.
We didn't even have a sub till like 8 o'clock.
But don't worry, you didn't even have us up till like 8 o'clock anyway. So I'm
It was,
so I'm sure you all just worked on the quiz anyway.
it was Santa.
Yeah,
I don't like that.
I imagine he just sat here. That I don't read a took attendance, newspaper.
He talks so quiet whenever he takes attendance, like in English the other day, when I was subbing there, I didn't even know he called my name. And then someone was like, well, he's right there. And I was like,
Well, I mean, I gave him a thing with your pictures on him in your seat. So like, I imagine he probably
I
could.
don't think he called us in order.
Oh, no, he was just calling people, definitely not in order. And
He
if
didn't
knew
even
you,
say
he
or-
skipped you. And so I'm sitting here like, did you not see? He was like, oh, I know you, I got you. I was like, oh.
I like Mr.
So then you don't say anything, like say it and be like.
Sure.
"You got it."
Mr. Wilson's still be accepted.
Mr. Wilson,
He's Mr. Like I don't know. And he's-
Yes, you do.
I'm just waiting on.
Do it. Do
Actually,
U
I
times
know-
B.
I know how to do B. Yeah, then how do you do that by W?
Well, this is scalar, right? If you know how to do 2 times
Oh,
B, you
wait,
know.
so if it's just U, it's just whatever you get for U times V and then
Multiply by W.
distributed into W.
That's right. All right, well, Jacob, I think you're next up in the line. All right, what do you think I should do first for A?
U dot V, that one.
What is that?
That one is, wait, let me think, I didn't write it down.
That's okay.
Okay, yeah. It's, -2, okay.
Uh-huh,
minus
and
12, which is -14.
so we get this.
And then you multiply
Oh,
by
golly.
the 1 minus, 1 and -2, okay. So you get -14 and 20.
Perfect. Good job. Sorry, Hayden, what do you think about for B?
It's -1 times 4.
Oh, hold on, wrong notation, -1, that should be a parenthesis. -1 times 4 plus 3 times -8. Everyone see where the 4 and the -8 came from? That's a double V. All right, 4, -8. And if we do that, what do we get? Is it 28? Yeah, very good. All right, last melon I'm gonna do, because I want to show you a different way. All of you could have done, the square root of -1 squared plus 3 squared. Right? A different way to do that is we know that U dot U is equal to the magnitude squared. Right? So if I just do U dot U, -1 times -1 plus 3 times 3, I would get 10. And if 10 is equal to the magnitude squared, then the square root of 10 would be the magnitude. That's actually the exact same thing, right? It's the component squared plus the component squared, square root. Yay? So in other words, the magnitude of any vector is the square root of its dot product with itself. All right, any questions about this, or does anybody need more time to write? And that was the hard stuff. That was like, hey, here's the heat. Though I will say the work stuff we do at the end, the application is probably the hardest. But to be honest, you don't really do dot product with it. I'm not actually sure why they decided to say, to put that in this lesson. It would have been just as fine in 6.3, but whatever. We'll live. All right. So next thing we're gonna do is also not too bad. It's to find the angle between two vectors. So if you have a vector u and a vector v, and you want to find this angle between them, just do this formula down here. Cosine of your angle is equal to the dot product of u and v over the magnitude of u times the magnitude of v. Note that this will always give you the angle that is it will always give you the minor angle, not the major angle. Oh, that's not the right tool. Here's the right tool. Do you know what I mean by that? But really, between u and v, there's two angles, right? There's theta 1, which is this minor angle here, and there's theta 2, which is this major angle here, right? This formula always gives you the minor angle, the one between 0 and 180 degrees, which is the one that in most contexts, right, is what you want, but not all. Of course, if you know what one of them is, you can find the other, right? The two have to add up to 360. And in almost all contexts, and I think all contexts for your homework, you want the minor angle anyway, right? But just in case, if you're working for NASA one day, right, and it turns out you really wanted the major angle for the problem that you're doing with the Jupiter rover, okay? Don't send me an email that says, Mr. Lake, I used your formula to try to find the major angle and it gave me the wrong one. Now the Jupiter rover is bent itself in half. Well, when you're working for NASA, right? Actually, that's probably not true. Questions on this? Does everyone have the formula written down? Anybody need more time to write? All right, let's do an example. So for example, let's say if we have u is 4,3 and v is 3,5. We want to find the angle between them. Again, you don't need to draw a picture for this one, but it might help you if you did, just to get like context of what's happening in this problem. So this would be vector u. And this would be vector v. Oh, that's a little too short. Let's try right there. And what we're finding is this angle, theta, between the two vectors. To do that, we're just going to use our formula. Cosine of theta is equal to the dot product of u and v over the magnitude of u times the magnitude of v. Which means the cosine of theta is equal to 4 times 3 plus 3 times 5 over the square root of 4 squared plus 3 squared times the square root of 3 squared plus 5 squared. So what's that? That's 12 and 15 or 27. Over 5 square roots of 34. And now we look at the unit circle. No, I'm just kidding. We're just going to do it in calculator. So the cosine inverse of that, type that into the old calculator. Easy boot. And again, you won't need to worry about what quadrant it is in or whatever. Whatever your calculator gives you as your answer is the answer. And if you typed it in correctly, you should get 22.166 degrees. All right, I did probably a little bit more work than you needed to. You could, once you have this all in numbers, I mean, you can just type it into your calculator right here, right? And take the cosine inverse. I mean, if your answer is going to be a decimal anyway, then just find out what this decimal is to begin with and take its our cosine. You don't actually need to simplify it first and then take the arc cosine. Yay? See? Even that's not too bad. I feel like that's okay. All right, so then I think the last thing we're gonna have time for. Ooh, will we have time for that? We might. Ooh, we'll see. Let's try this one and see how much time we have left. All right, find the angle between these two vectors. 3 minutes on the clock. We'll use the next page. All right. What'd you get, Mariah? Or how do we do this problem? That's exactly right. And so if we do the cosine inverse of that, and you can't just type that whole thing into your calculator, but if you want to simplify it a little bit, that's 2 + 3 over the square root of 5 times the square root of 10. You should get the angle is exactly 45 degrees. Yay? Any questions about that? Okay. Last thing going in your notes then. We won't do the practice. We'll just do this part. Two vectors, u and v, are perpendicular if their dot product is 0. And then we'll do this guide of practice for bell work tomorrow. So once you write down this statement, you're good to go. Pack up. Two vectors, u and v, are perpendicular, also known as orthogonal. If you have ever played a board game, they'll be like, you're only allowed to move orthogonally, right? Not diagonally. U and V are orthogonal if their dot product is 0. Or psychology. I was gonna say, if you want to do business degree at Washburn, they require you to check. What I have, like, one, which is actually, it's actually applied calculus. If you take AP Calc, you get credit for Calc 151, which counts for that, and then you wouldn't need to take any math in college besides maybe stats, something else you could actually also. Psychology, though, I think it's called algebra. So I told him, so he asked if you could do college algebra. I told him, easy. In fact, it might be better for you to do calculus, because it'll give you credit for college algebra and for that calc one that you might need for business. And I think we could do that now. I don't know, easy, but I think you could do it. So ultimately up to you what the route you want to go. But I thought I'd let you know. Well, for Washburn, they require either a 3 or a 4. If you get a 4, it's automatic. If you get a 3, I think they look at your ACT score, your GPA, and I just help to see if it's good enough. Which again can be difficult. But to get a 3, you need 40% of the right on the test. To get a 4, you need 50%. Maybe it's 30-40. So it's doable, and it would save you 5 credit hours having to take Calc 1 in college. But if you're not sure, if you think maybe are leaning towards psychology more than that, then if you just take college algebra and then do applied calc there. No, I would think. Yeah.
Thank you.
No problem. If you have any questions or anything about it, just let me know. I can help you.
Thank you.
No problem. is this. That is correct. Howdy. Howdy.